Okay, YouTube, in our last video, we had confronted the idea of finding a multiplicative inverse matrix if we're given an initial matrix. And that way that we went through essentially was to take our initial matrix A and write it in this doubly augmented matrix with our identity matrix on the right. And what we had done was we transformed the left side into I, thus transforming the right side into A inverse. And so neat thing about that is simply that it takes a while. Okay, because what you have to do is you have to write this doubly augmented matrix here. You have to do Gaussian elimination on the left to turn it into our identity matrix to get your, say, A inverse matrix. What I want to tell you is that we actually have a method that works uniquely with 2 by 2 matrices. And so what you see here is literally what we call the quick method for finding the multiplicative inverse of a 2 by 2 matrix. But what I want you to know is that this rule that we're about to use right here should, if A inverse exists, always allow you to find the multiplicative inverse of any 2 by 2 matrix. So let's go ahead and start with what this rule is. It says that if we are given some matrix that is a 2 by 2 and it is populated with these entries A, B, C, D, then our inverse matrix is 1 over the product of A and D minus the product of B and C. That thing times this entire matrix here, where you can see that some things have been changed from our initial matrix. So in terms of what do we see that is different about our inverse matrix here, let's write a few things. Starting with this, we say that the main diagonal entries switch spots. That is to say that when you look at this matrix right here, we said AD was our main diagonal. Well, it becomes DA. And looking at the opposing diagonal, which is what we call this one here, we say BC. Notice what happened to those. We made them negative, or we made them their opposites. So make the opposing diagonal entries their opposite. Okay. And so the last thing we're going to do here is multiply the entire matrix by the scalar 1 over, and we say BC, AD minus BC. And so let's talk about AD and BC here. As a matter of fact, what I want to point out is that AD is the product of the main diagonal entries. And so as we look at our matrix here, you can see that A and D lie along this main diagonal. Really, to find this AD minus BC, we're taking the product of the main diagonal. We're subtracting off BC, which is the product of the opposing diagonal. So we'll make a little note here about that as well. BC is the product of the opposing diagonal. So this really quick rule right here, one thing that I do want to mention is that sometimes it doesn't work. And those cases in which it doesn't work, we would say that A, just generally speaking, it doesn't have an inverse. And so when wouldn't this work? Well, looking at this entire expression for A inverse, where A inverse is this 1 over this product, difference of products here, times this rearranged and resituated matrix. Well, if AD minus BC, if this equals 0, then all of a sudden we're going to say then A doesn't have a multiplicative inverse. And so what I want to do here is take a look at this matrix A and basically just throw out this rule here. It's a 2 by 2 matrix. Could we find its inverse matrix pretty quickly? And so I think we can. We're going to say that A inverse is 1 over AD minus BC. So I'm going to leave a little blank spot here for now. And the first thing that I like to do is just go over to my initial matrix and do what we know, which is switch our main diagonal entries around. And we're going to make opposite the entries on the other diagonal, the opposing diagonal. So right now we switched and we negated the opposing. And when we look at AD minus BC, we get negative 1 times a positive 4. Here's a negative 4 plus, minus, big time minus. 3 times a negative 2 here, we get a negative 6. So with our minus a minus here, plus a plus, we get a negative 4 and a positive 6. I think that adds up to be a 2. So we get 1/2 times 4, 2, negative 3, and negative 1. So one thing that I want to point out here is this. I'm going to put a box around this. This is the inverse matrix right here, and I know that it has to have an inverse because we didn't get 0 when we did AD minus BC. Also this, we should always, if possible, at least express this as a matrix where this scalar has been distributed through. So we would say that 4 times a half, that'd be 2. 2 times a half, that'd be 1. Negative 3 times a half is negative 3 halves, and negative 1 times a positive a half is negative 1/2. So this would be our inverse matrix right here. Well, what I'd like to do is verify that this is actually indeed the inverse of the initial matrix. So what we're going to do is we're going to check this by taking A times A inverse and seeing, do we get I? So let's go ahead and line this up. Suppose we would have A on the left here and our supposed A inverse on the right. So we had our initial matrix is negative 1, negative 2, 3, 4. And then over here we're going to say that we had 2, 1, negative 3 halves. Okay, and negative 1/2. So this may look undesirable, but it certainly does work, and we certainly do get a 2 by 2 for a response here. 2 by 2 times a 2 by 2, the inner dimensions match, and the outer dimensions are the dimensions of our product. Let's go ahead and fill these in, but what I want you to see is we should get the identity matrix. Let's go ahead and start with our first row, first column. We get negative 1 times a 2, which is a negative 2, plus, and then we get this, interestingly, we get a negative 2 times a negative 3/2. Let me show you this here. Negative 2 times a negative 3/2. Look what's going to happen here. We get a positive, and our 2's kick out, so we get a 3. So this negative 2 plus a positive 3, interestingly enough, is going to give us a 1 here. Now moving over to the first row, second column, we get negative 1 times 1, which is 0. Okay, plus, I suppose, hold on a second here. Negative 1 times 1, move over, move down, we get a negative 2 times a negative 1 times 1. Sorry, brain dead this morning. Negative 1 times 1 is a negative 1, plus a negative 2 times a negative 1/2 is a 1 there. So that's where our 0 is going to come from there. Looking at our second row, first column, we get 3 times 2 is 6, plus now 4 times negative 3/2. If we do 4 times negative 3/2, similar things happen here, except for our 4 doesn't cancel all the way out. We get a 1 and a 2, so 2 times a negative 3 is a negative 6. So we get a negative 6 here. And then last but not least, and that's a 0 when we add those, our second row and second column here, we get 3 times 1, which is 3, plus now 4 times negative 1/2. 4 times a negative 1/2. I guess our 4 and our 2 would cross cancel with the common factor of 2. We get 2 times negative 1 was a negative 2. So we get a negative 2 here, which gives us a 1. So these are indeed inverses of one another, and that would just be our shortcut for finding inverse matrices of just 2 by 2s right there. Cheers.